Hello everyone. Once again, welcome back to my YouTube channel. So today in this section, we are going to learn about two-way ANOVA. What is ANOVA? ANOVA is analysis of variance. Is a statistical test used to analyze the difference between the means of more than two groups. In ANOVA, we have two different types, one-way ANOVA and the two-way ANOVA. A one-way ANOVA uses one independent variable, while a two-way ANOVA uses two independent variables. One-way ANOVA example as a crop researcher, you want to test the effect of three different fertilizer mixtures on a crop yield. So you can use a one-way ANOVA to find out if there is a difference in crop yield between the groups. Two-way ANOVA. A two-way ANOVA is used to estimate how the mean of a quantitative variable changes according to the levels of two categorical variables. Uses a two-way ANOVA when you want to know how two independent variables in the combination affect a dependent variable. Let us look at the example. You are researching which type of a fertilizer and planting density produces the greatest crop yield in a field experiment. So you assign a different crop plots in a field to a combination of a fertilizer type 1, 2 or a 3 and planting density 1 is for a low density and 2 is for a high density and measures the final crop yield in bushels per acre at harvest time. So now you can use a two-way ANOVA to find out if fertilizer type and planting density have an effect on an average crop yield. So let us look at when to use this two-way ANOVA. You can use a two-way ANOVA when you have a collected data on a quantitative dependent variable at multiple levels of two categorical independent variables. A quantitative variable represents amounts or counts of things. It can be divided to find a group mean. So as we consider from a previous example, a fertilizer types 1, 2 and 3 are the three levels within the categorical variable fertilizer type, whereas planting densities 1 and 2 are the levels within the categorical variable planting density. So how does the ANOVA test work? A two-way ANOVA with interaction tests three null hypotheses at the same time. So there is no difference in group means at any level of the first independent variable. And the second step is that there is no difference in group means at any level of the second independent variable. And the third step is the effect of one independent variable does not depend on the effect of the other independent variable. Hence, a two-way ANOVA without interactions only tests the first two of these hypotheses. So let us look at the difference between the null hypothesis and the alternate hypothesis. There is no difference in average field for any fertilizer type in null hypothesis, whereas in alternate hypothesis there is a difference in average field by fertilizer type. So whereas in null hypothesis there is no difference in average yield at either planting density, whereas in alternate hypothesis there is a difference in average yield by planting density. Whereas in null hypothesis, the effect of one independent variable on an average yield does not depend on the effect of the other independent variable, whereas in alternate hypothesis, there is an interaction effect between the planting density and fertilizer type on an average yield. So let us look at the assumptions of a two-way ANOVA. So to use a two-way ANOVA, your data should meet certain assumptions. A two-way ANOVA makes all the normal assumptions of a parametric test of difference, homogeneity of variance. The variation around the mean of each group being compared should be similar among all the groups. If your data don't meet this assumption, you may be able to use a non-parametric alternative. Independence of observations. Your independent variables should not be dependent one on another. That is, one should not cause the other. This is impossible to test with the categorical variables. It can only be ensured by good experimental design. In addition, your dependent variable should represent unique observations. That is, your observations should be grouped within locations or an individuals. If your data don't meet this assumption, that is, if you set up an experimental treatments within a blocks, you can include a blocking variable and or use a repeated measures ANOVA. Normally distributed dependent variable. The values of the dependent variable should follow a bell curve. They should be normally distributed. Meet this assumption. You can try a data information. In a crop yield example, the response variable is normally distributed and we can check for the homogeneity and running the model. The experimental treatments were set up within blocks in the field with found a very possible combination of a fertilizer type of planting density, so we should include this as a model. So how to perform a two-way ANOVA? So the data set from our imaginary crop yield experiment includes the observation of a final crop yield, type of a fertilizer used, fertilizer type 1, 2 or a 3, and then a planting density 1 for a low density where 2 represents an high density and in a block in field 1, 2, 3, 4. The two-way ANOVA will test whether the independent variables fertilizer type and an planting density have an effect on the dependent variable like as a average crop yield. But there are some other possible sources of variation in data that we want to take into an account. We applied our experimental treatment in blocks, so we want to know if planting block makes a difference to average crop yield. We also want to check if there is an interaction effect between two independent variables. For example, it's possible that planting density affects the plant's ability to take up a fertilizer because we have a few different possible relationships between our variables. We will compare three models: a two-way ANOVA without any interaction or a blocking variable, a two-way ANOVA with interactions but with no blocking variable, a two-way ANOVA with interactions and with the blocking variable. Whereas module 1 assumes there is no interaction between two independent variables, where module 2 assumes that there is an interaction between the two independent variables, and module 3 assumes there is an interaction between the variable and that blocking variable is an important source of variation in the data. Running all three versions of the two-way ANOVA with our data and then comparing the models, we can efficiently run which combinations are important for describing the data and see whether the planting block matters furthermore. Hence, this is not the only way to do the analysis, but it is good method for efficiently comparing the models based on what reasons of a combination of variables. Hence, this is the end of today's session. Thank you.